So very good morning to all of you. I hope I'm properly audible. Very good morning to all of you and welcome to today's webinar on the Internet of Things. Please give me the confirmation through the chat box if I'm properly audible to all of you. I hope I'm properly audible. Please give me the confirmation through the chat. Okay, so let's start with the today's webinar. I hope I'm properly audible to all of you. Great. Okay. Thank you for the confirmation and let's continue the today's session. And today we'll talk about the one of the very emerging and latest technology, that is Internet of Things. Nowadays, all over the industries, manufacturing, logistics, healthcare, and different service product company, they're implementing the IoT or they're adopting this kind of technology. And we'll understand this architecture of IoT and we'll also talk about the different applications of it. So let's start with this particular part. Okay, so Internet of Things, we can simply define that it is a network between different physical devices. In such way, each physical device will able to share the information or data to other physical device. Like Internet stand for network and things means physical devices. That physical device could be anything like industrial robot, machines, sprinkler, fridge, TV, AC, cooler, sprinkler, human body. It could be anything. So network between all physical devices. In such way, each physical device will able to share the information or data to other physical device. We can simply say this is the IoT. Okay. So nowadays, all of the kind of manufacturing industries, logistic, healthcare sector, smart city, into different domains, uh, the companies are adopting this particular technology. And we'll also talk about the different applications, not only into the manufacturing, sports, and particular smart city, even the different kind of the applications related to the healthcare sector, smart wearable devices we are using nowadays. And it also known as IIoT. Whenever we are going to adopt these technologies into the manufacturing industry to design the smart manufacturing or the connected manufacturing industries, it's known as IIoT, Industrial Internet of Things. It's also known as IoE, Internet of Everything, Sensor for Everything, the next generation of internet, or different kind of terms that is used to define the particular IoT. And we'll talk about this all over the architecture and understand, and then after we'll go with some demo part also. Okay. So as we discuss, so internet means kind of network, and we can internet means kind of the network, and the physical device means different physical devices, and that kind of the normal home appliance or the particular industrial robot, machines, sprinkler. So we can create a network between different physical devices. In such way, each physical device will able to share the information or data to other physical device. So we say that this is the kind of example of the IoT. Okay. And generally we are using the industry adopting this particular technologies. Why? Because one of the reason is because it's convert our normal physical device into the smart physical device, because we say they're smart and connected. We want a smart and intelligence devices. So IoT convert our normal device into the smart device. Okay. And if I talk about that, how to implement this particular technology into the real time, because we want a physical device will able to communicate and able to share some data, right? So here we work on some microcontroller embedded system, wireless networking technologies, sensor, actuator, protocol, cloud platforms, security, database, different things that we use it, and we can be implement this particular part, this particular technologies. And you can see here, normally like ATM machine and the phones, it's always connected to the network or particular internet. That's why we generally say ATM machine is a smart ATM machine, the phones are the smart phones, because these devices are always connected to the particular network and able to share the information or the data. Nowadays we want a same kind of things, like our particular all over the in the city, all over the traffic signals is generally based on some kind of the delay time seconds and all. So what we want, if the all over the traffic signals were able to communicate and able to share their data the real time, so we say this is the kind of, and based on that it will take perform some action. So we'll say this is the example of the smart city, and using of the IoT we can easily implement this particular part, not only the smart into the city but into the manufacturing industry, by connecting the all over the industrial robot or the machines to the particular server. In such way they will able to communicate and share the information or the data, so that it generally increase the productivity and also improve the quality of the particular product. And if I say the IoT is generally into three different sector, you can just normally divide it: IoT development, IoT security, and IoT analytics. First, we'll talk about the IoT development part, and here we generally discuss that how to design the IoT enabled devices. Okay, so that will also discuss into the detail. We'll talk about the different microcontroller, sensor, actuator, cloud platforms, and we'll also talk about some advanced technologies like augmented reality with the IoT, artificial intelligence with the IoT part. Okay, so because nowadays in the manufacturing industry, they're also looking for some remote maintenance kind of the solution, predictive maintenance kind of solution. So here we'll implement the IoT with the AI and IoT with the augmented reality. So that will also discuss into the detail. Okay. If I talk about the future of the IoT, so now the different organizations, different industries that are adopting this particular technology into the different domains, like into the home, into the smart city, into the production or the manufacturing industry, into the logistic industry. So by using it's make human life very easier. So according to the NASCOM and according to the different organization, the end of the 2020, 40 to 80 billion devices will be connected to the internet or the network, and all of the devices will able to communicate and share the information or the data. Okay, I hope it's visible for all of you, right? Can you please give me the confirmation? Yeah, thank you for the confirmation. Okay. So nowadays, if you can see, every person having at least the 2 or 3 devices, which is always connected to the network or a particular internet, like mobile phone, laptop. Okay, but after sometimes every person will have at least 10 devices. Means every person will be used the particular at least 10 devices. It's not visible. Let me check it. Yeah, I think please check the particular internet connection from your side. I think it should be the visible. Okay, half part of. No, that is fine. This is the part of the PPT. Okay. Okay. Maybe there's some issue from your side, some internet issue. So make sure that internet connection is perfect. Okay. So nowadays, every person is having at least we use a kind of the 3 or 4 devices in their daily life, which generally always connected to the network part. But after the sometimes, like because people are adopting this particular technologies, why one of the reason is make human life very easier. And that's why after some couple of year, the persons will use the different devices, at least 10 devices, into their daily routines. That is the based on IoT part, like smart specs, smart business card or visiting card. Okay, smart ring. Obviously, we are using the smart mobile phones or the laptop. But after some couple of years, every persons will have at least 10 devices which will be always connected to the network, or it will be the example of the kind of IoT based on the IoT. Yeah, definitely. We'll discuss the different projects and different particular uh, content part into the detail later on. First, let's go with this particular understand the architecture of IoT, and after that, we'll discuss the different very industrial projects like augmented reality with the IoT and the particular AWS, Amazon Web Services, different cloud services with the IoT part. Then predictive maintenance, different kind of the examples that will be discussed. Okay. First, let's go through the some basic part, and once the everyone will become on the same page, then after we'll discuss different applications, and we'll also talk about the different projects that will be do that. Okay. So in the simple language, we can say the IoT is the Internet of Things is also known as the Internet of Objects, refers to the wireless network between all over the objects or the physical devices. So when we talk about the IoT part, so generally we use a different normal microcontroller, sensor, actuator, and we connect all over the physical devices in such way this physical device will able to share the information or the data. So normally we use a different wireless networking technologies in to build a wireless network between a different physical devices or to connect the different physical devices like kind of the Zigbee, Bluetooth, NFC, LoRaWAN, Sigfox, Narrowband IoT, Wi-Fi, different kind of wireless networking technology that we can be used it to build a wireless network between different physical devices. But when we talk about the particular industrial IoT into the manufacturing industry or the production industry, okay, when we talk about the industrial IoT or talk about the implementation of the IoT into the manufacturing or the production industry, we generally use the industrial controller like a PLCs, DCS, and different controller, and we generally connect to the PLC, SCADA, HMI, or the particular ERP or MES systems, ERP solution, and connect to the all over the raw material to the final product, and we can have a collect the data from each and every uh, stage or each and every point of the particular position of our particular particular raw materials product. We can collect all over the data. We generally connect the machine material and all over the health of the particular machines, all over the materials, their data information, and the product data. And that information will help us to take a good business decisions. And over there, we use a different profit bus, Ethernet, different kind of the connecting cable to connect the all over the MES, ERP, and PLCs and SCADA systems, and to connect to the particular server part. And then after we work on different protocols like OPC, UA, and QTT, different protocols to connect with the server and collect the all over the data. That will be also discussed into the detail, the architecture of industrial IoT. Okay. So either we can be also says the new form of the communication between people and between things and themselves. Means it's kind of the new communication technologies so that different physical devices can be communicate with the other physical devices and also with the humans and easily can share the data. So IoT makes the devices the smarter. Like when we say that we are implementing the IoT image, this now we are going to convert our normal physical device into the smart device. And that's why when we say the smart home, smart city, or the smart world, like smart world, smart home means all of our normal home appliance home devices will able to communicate and able to share the information or the data. When we say the smart city, like all over the CCTV camera or the particular street light are connected and able to share the information or the data. Let me give the one example of it. Okay, most of the US and Canada, the Europe, most of the European countries, they're implementing the IoT to build a smart city. Even into the US, their companies are using the IoT to connect all of the traffic signals. So the traffic signals will able to take some decisions and able to communicate also. Like even they're also working on the different kind, they're also implementing into the different kind of applications. Suppose that if there's any kind of uh, fire brigade or any kind of the particular ambulance, now ambulance want to reach on the some other destination or the particular hospital. So if the all over the street light, sorry, traffic signals will be based on the time delay, so maybe the ambulance or the particular fire brigade will face the loss of the traffic challenges. But if the all of the traffic signals will able to connect and able to communicate using to the IoT technologies, so particular driver of the ambulance or fire brigade will share the address of particular GPS location of the particular destination or the particular hospital, and based on that all of the traffic signals will be work in such way, because now the traffic signals will able to communicate with each other. So the traffic signals will work in the particular destination or the particular area in such way that the particular ambulance or the uh, fire brigade will able to reach the destination into the sort of time span. Okay, so now here what happened, all of the traffic signals will able to communicate and share the information, so that based on the requirements it can be work, and the ambulance or into the some critical situations ambulance or the some fire brigade will able to reach the destination within the very minimum time. So such kind of the example into the smart city, and even also we can connect to all over the street light into the some network. Like right now what happened, if any street light is not working, it's take too much times to replace and to come to know about that the exact reasons behind it, right? So if the all of the street light will connected, and if there is any problems occur in any particular street light, it will be send the some notification or some information to the server, and now server on the particular monitoring system, now server having the data, we can come to know about there some kind of the issue is coming in the particular in this particular street light, and we can easily replace it. And not only this particular part, even the most of cities like Vijayawada, Hyderabad, Delhi, and Mumbai, if you park your particular car into the no park your particular vehicle into the no mark parking places, it will be send us some information or data to the particular Mahanagar Palika, and based on that, because they are implementing the some sensor on the no parking places on the road. So whenever any particular persons will be parked the kind of a vehicle, it will be send us some notification or the information to the server. Now the particular service provider company having the data like this particular, in this particular place there is some, on the no parking places there is some kind of the kind of vehicle, so based on that it will be perform some action. Okay, so in the loss of example into the smart city, by connecting the all of street lights or the particular the traffic signals, and even in the logistics sectors into the monitoring the all over the environmental gases, and to collect the huge amount of information, because using the IoT we can connect to all of the physical devices so that they can be communicated, but also we can collect the huge amount of the data, and then we can be use those data into the different way by using the big data analytics or artificial intelligence, machine learning kind of the technologies. Okay. So what are the benefit of it? And this is the one of the reason why all of the companies and is booming in the market. Why? Because for the IoT, it doesn't matter what is the physical device. We can implement it anywhere, anytime, and it with any kind of the devices. It doesn't matter is your like what is your physical device, is kind of any industrial robot or the machine, or is some kind of the sprinkler or the human body or the vegetable. It could be anything, and we can implement it anywhere, anytime, and with any kind of the devices. And this is one of the reasons all over the industries nowadays implementing these technologies, and the loss of uh, very big market in this kind of the domain also. And one of the main reason is not related to the particular phys engineering branch. Like here we'll talk about the some embedded system also, some database also, some cloud solution also. If you're implementing it into the some manufacturing industry or the production industries. Okay, still all of you are facing the same issue. Can you please give me the confirmation? Like, is it visible? Okay. Please make sure that all of you, your internet connection is the perfect. If you are facing some kind of the challenges, okay. Yeah, right now I'm only on the same page. Okay, so on the particular benefit, we'll go with that, and then after I'm just trying to explain this particular part. Then after them, so definitely you'll be get the different pages also. Okay, so the one of the benefit is we can implement it anywhere, anytime, and with any kind of the devices. Okay. So now, if I talk about that, now all of the manufacturing industry nowadays they're implementing it. All of the production, manufacturing, even the government bodies are using. The loss of the service product company, they're also using this particular part. Even technical, non-technical, it's not something only the manufacturing industry can be used it. Even the loss of the companies or the software development companies, they are working into the IoT domain to work on IoT data. Analytics company, they're working on the particular IoT domain to understand and work on to provide the solution of the IoT data. And also lots of the companies, because through the IoT, we can collect the huge amount of data, but how to understand this data, how to work on data, and how to find out the some meaningful information from the data. That's part we do into the IoT analytics by using the big data analytics and the particular artificial intelligence kind of the techniques. So lots of the startups and lots of the company, they're also providing a solution to the manufacturing industries or different companies uh, uh, on the analytic solution they generally provide, because that is something very important. If you We can collect the huge amount of the data, but if you won't be able to understand, if you won't be able to find out some useful information from the data, it doesn't make any sense. Okay, so even so lots of the company, they're also working into the analytics part. Lots of the software development company, they generally build a different kind of the software and their applications so that we can be easily use this particular part. Okay, so now to improve the governance and the management sector, reduce the cost and improve the efficiency, because in the manufacturing industry, if you can collect the all of our data, because data is something represent information about any physical device or related to any particular things. Like suppose that, let me give you one example of it. And because nowadays all of the manufacturing industry, they're also adapting, they're also trying to implement this particular part. We know that into the manufacturing industry, there are lots of the machines, industrial robot or industrial machine, heavy machine. We generally use it for the different purpose. And into the every machine, sometimes some different kind of the failure occur. And maybe the reason behind the particular problem or particular issue is different factor like high temperature, high pressure, high vibration, or more than 15-20 factor or loose connection, right? High stress strain, or maybe 15-20 factor, right? So due to that, so due to that, some kind of the failure, some kind of the issue when comes, so all of them maintenance engineer need to stop all over the particular production systems for the particular time. So it's very big loss for the particular company, you can say, or the industries. So now the manufacturing industry, they're moving, they want to go with the continuous manufacturing for the 2 years, for the 3 years, continuous manufacturing. And that's something one of the application of the industry 4.0, fourth revolution of the manufacturing industry. But in order to do the continuous manufacturing, so they're implementing the IoT and the IoT analytics or the big data analytics or artificial intelligence kind of the techniques over there. Using the IoT, they can collect all of the factor data who is very responsible for such kind of the failure. Now suppose that if you have all of the data which is very responsible for such kind of the failure in a particular machine, then using those data we can store some data into the some particular places, either on the local network, on the server, or on the cloud, some database we can restore it. And using to the big data analytics and artificial intelligence machine learning techniques, we can build some solution like predictive maintenance. We can predict that after the 2 days, after the 3 days, after the 5 hour, some kind of the failure will be come. So meanwhile, the maintenance engineer can be resolve that kind of the issue. Yeah, definitely we'll post this all over the videos part and all over the the PPTs and the tutorials will send you through the email also. So don't worry, please go with this particular part and understand the architecture, because that's something very important. And we'll do the some practical also. Don't worry about that. Okay, we'll do some practical also and discuss into the detail with the different applications. And now, because also the company is implementing the augmented reality with the IoT part, because nowadays the virtual reality, augmented reality, and mixed reality, we are adopting into the IoT manufacturing industry also for remote maintenance kind of the applications. Okay, so even we'll also do this particular part, like we'll work on the augmented reality and how to build the application of the augmented reality, and how to resolve the issue with the remote maintenance. Suppose that what happened in the manufacturing industry, if there's any kind of the product, or there's any kind of the company's product service on the field. Okay, now there's a one field engineer or the field person who generally used to go on the different places and resolve the particular challenges. But it's not compulsory that persons have a knowledge of all over the particular stream, is electronics, mechanical, electrical, all over the part. So if there is some particular, suppose that if the field engineer is good into the some electronics part, but there is some kind of the challenges or issue coming into the electrical part, so it's become very big challenge for the field engineer to resolve that kind of issue. Then again, the companies need to hire some electrical engineer persons to resolve that kind of issue. But in such cases, we can build a remote maintenance kind of the solutions using the augmented reality and with the IoT. And we can share the live data, and particular persons from remote location can access the all over live data and live information of each and every part of the particular machine, and easily guide to the field persons how to resolve such kind of the challenges or issue. So that application will also build. So first thing is, what is the augmented reality? There are the two things, virtual reality and augmented reality. Okay, in the virtual reality, what we do, we generally build the virtual applications of our imaginations, or if you have something concept, if you have some particular concept in your mind, if you have some kind of the dream, so you can build a virtual, you can give the some kind of the play. Okay, you can build it into the some reality format, like we play different games. Okay, so this is kind of the application of the virtual reality. We generally draw the all over our imaginations into the some kind of the video formats. You can say, simply say, augmented reality is something we are trying to add something virtual things on the real world. We are trying to add some virtual things on the real world, like example of the Pokemon Go. Okay, we are trying to add some virtual world into the virtual things on the real world. This is something augmented reality. I mean, suppose that on the let me give the one example of it. Suppose that from your home, like suppose that there's a one machines. Okay, and now you build some application of the augmented reality with the IoT. So from any positions, using your mobile phone camera or using your particular some HoloLens kind of the devices, you can scan the some floor or some kind of that image. So virtual dashboard will be appear in front of your eyes, virtual dashboards. And whenever you virtual dashboard, whenever you'll be press some virtual button in the air, you're able to control any particular physical devices, or you're able to get a data from all over the machines. Maybe lots of the into Hollywood movies, we generally say that lots of the virtual dashboards appear into the some air, and we can easily click on that and control the different things. We can able to perform some action. So such kind of things we do into the augmented reality. We're trying to add the virtual things or virtual world into the real place. And by interfacing with the IoT, we can be control it and also collect monitor all of the data. Okay, so this kind of applications industry also adopting to resolve them remote maintenance kind of the challenges or issue. No, that's something different, Manish. Jarvis is something different. Maybe you seen into the loss of the Hollywood movies, that the loss of the virtual dashboards or appears into the air, and whenever we press or move by moving our hand or by gesture our particular hand, it will able the dashboard or the loss of things on the dashboard will be able to move and perform some action. So such kind of things we generally do here. Okay, and that is also the part in our course content. Like if you'll join this particular part, so we'll also work on augmented reality and IoT and such kind of the very cool applications part. Okay, so let's move with that. And so so end to end, what we are doing through the IoT part, we are collecting huge amount of data. We are collecting the huge amount of data, or that data is what, there is something information about the particular physical device. Suppose that if you're by implementing the IoT on the any particular industrial robot or industrial machine, we can collect a huge amount of data or the information, and that information is generally represent the health of the particular physical machine or the robot. Suppose that if you are implementing the IoT on any industrial machine and you're collecting all our data, which data, which data? Suppose that some high pressure, high temperature, vibration, these are some factor which is highly responsible for such kind of the failure. Now, you want to build some applications so you can predict their failure, so that you can be predict their failure, or you can predict the whenever its machine requires such kind of the maintenance. Suppose that you want to build some application for your car after that, so that you'll get a notification that if any maintenance is required in your car, you want to build such kind of application. So we know that if there is some kind of the failure or challenges coming into the car, so there is some specific reason, like it's maybe into the suspension, steering, or some particular places. Okay, so what we can do, if we can implement the loss by using the IoT, if we can interface the loss of sensor, wireless networking technology, so we can collect all our data into some particular place, and by using the AI techniques, we can build some application so that if there is any maintenance will be required in your car, you'll get some notification. Okay, so what we are doing, that we are generally working on the data that we are collecting through the IoT by using the big data analytics and artificial intelligence technology. Okay, but in order to collect the data, we are implementing the IoT, and once that data is something information, and if you have information, you can do the loss of things. That's why we say that information is a great way to reduce the waste and increase the efficiency. And through the IoT, we are generally collect such kind of information or data. And one of the part of the IoT is IoT analytics, because we discuss in the IoT domain that the main three domain, that is main three sub part. One is the IoT development, security, and analytics. In the development part, we use different microcontrollers, sensor, actuator, cloud platforms, wireless networking technologies. Okay, and we try to implement the IoT enabled devices. In the security part, we generally work on the security feature, hardware security, network security, database security, cloud security. We work on security features because through IoT is the information that we are sharing, or the device is generally sharing to sending one device to another device, or communicating with the peoples. That is a very important or private. We do not want to share with a third person. So the security is a very important whenever we talk about the IoT part. So through in the IoT security part, we generally add the different security layers on the hardware, on the network, on the data, on the cloud, on the database also, so that third persons won't be able to access the particular our data, and to keep our data very private or secure, we generally add a different security layer over there. And after that, IoT analytics, we use a different big data analytics or the AI tools like machine learning, deep learning kind of the transfer learning kind of the uh, tools or the techniques to work on IoT data and design build some kind of the application of the predictive maintenance recommendation systems, or remote maintenance kind of the applications. Because nowadays we are using the IoT into the sports, into the different places, into the construction industry also we are using the IoT and the particular AI, different places that we are using this particular part. Because for the IoT, it doesn't matter the physical device, we can implement any kind of the domains, any places, anywhere we can be implemented and build the solutions over there. Okay, so all of you, if you have any question, you can be just let me know through the chat box. You can just send me through the chat box so that we can be discuss also. Okay, but nowadays into the India, the loss of the big applications, like we are loss of the smart city projects is going on, um, based on the LoRaWAN wireless networking technologies. Okay, it generally cover the up to 15 kilometer the range. Okay, so Okay, the one question is work particular analytics. Okay, let me talk about. Through the IoT part, we can collect the huge amount of data. Okay, the data is mean something, some factor data, like maybe the images, audio, video. Your data may be in the format of the audio, video, string, numericals, value. It could be any particular format, right? So now, suppose if you have a loss of data, you won't be able to understand. Like suppose that if there's a one machine, in this machine, the you are collecting all of our data, means like temperature, humidity, or stress, strain, force, more than 15 factor. And these factors are very responsible for such kind of the failure. Now you want to predict that if any kind of the maintenance require before to the 3 days or 4 days, you want to predict that, like before to the 5 hours, if like you want to predict that if there's any kind of the maintenance will be required or any kind of the failure will become, you want to predict that. So we can collect a huge amount of data. Okay, the data something represent the information about some critical factor which are the highly responsible for such kind of the failure. Now, suppose that if you will just visualize or monitor this data, we won't be able to understand it, because if there are only the 2 3 factor, we can easily understand it and predict that kind of the things. But if they are the more than 15 20 factor, so it's not that much easy for the humans to do the prediction and understand the all over the part. So in such cases, we use a machine learning techniques. Okay, in such cases, we use a machine learning techniques like we build some intelligent software. Okay, so that it can learn from this data, and once it's learned, it's become the enough intelligence. Then after it can do the prediction part. Like after it can, whenever the live data will become into that intelligent software, it will be do the prediction that after the 2 hours, after the 5 hours, some kind of the failure will become. So we can also build over there some recommendations system. So recommendation engine will be recommending the different kind of the solution to the maintenance engineer. You should perform this action, you should be perform this action in this particular situation. So this is something part of the IoT analytics. Okay, so there's a lots of the question, let me just go with that. So some question is something, what are the some other sector in the industry where the IoT is used? Okay, so Kavya, like from in the IoT, like remote maintenance or the build the smart, because now all of the manufacturing industry, they are implementing the some small different application of industry 4.2. Okay, fourth revolution of the manufacturing industry. So using the remote maintenance is one of the applications. Predictive maintenance, sorry, remote maintenance, predictive maintenance, recommendation solutions. Okay, and by collecting all our data from ERP solutions, customer requirements, health of the particular machines, employees, production rate, all of we can take a huge business decisions also. We can take some, it will help us take some good business decisions. So through that it will be increase the particular productivity, or also into the safety and security. Now companies are also implementing it into the manufacturing industry to improve the safety of the employees. They are generally designing the IoT enable the hamlet or the mask. Okay, so the different applications is depend on the kind of the manufacturing or the production industries. Okay, so then after there's some questions like use of IoT into the medical field. Okay, so obviously into the medical healthcare sector is also the industries are implementing this particular technology. Let me give you some example of it. Nowadays, there's a loss of the product, the smart wearable devices that we can be easily use it, and it will be monitor the all over our particular healthcare, all over the monitor the particular data and do the some kind of the solution. Even you can see the loss of the mobile applications and loss of the smart wearable devices are coming in the market, which can be monitor the pulse rate and the particular heartbeat and the different pressure, the particular different kind of the application, the smart Android applications, where we can just put a particular data and it will be help us to monitor the all over the internal information and give the kind of the recommend the different kind of the solutions also. Like in the healthcare field, we also implementing to design or build the smart hospitals, and different wearable devices are also coming in the market which can monitor the particular heart rate and the different blood pressure and different kind of the attributes over there. Okay, so then after there are some how skills. Okay, what are the different? No, this is not specified for. This is one very common question. So how to start, how to learn this particular part, and how can I get start with the IoT part and get a certificates and okay, okay. So let's talk about in the IoT domain. There's no any kind of the very standard certificates because it's combination of the different technologies. Here we talk about the electronics, and this is not compulsory for the electronics students. A particular person's mechanicals, electronics, electricals, computer science, all of the different domain person can easily learn it and understand this particular technologies. But here we'll talk about the some basic electronics, okay? Some basic electronics, some communication protocols, some programming, some database, some cloud platforms. Okay, so we'll work on this all about the part. So you should be have first, you should have some particular basic knowledge about the microcontroller. Okay, again in our training part, like generally we start from the very scratch, like to the starting with the microcontroller. What is the microcontroller and what are the different microcontrollers are available in the market, how to interface different sensor actuator with the microcontroller, what about the different wireless networking technologies are available, what about the role of the cloud platform communication protocols like HTTP, MQTT, CoAP, XMPP, different cloud platforms like AWS IoT, Azure IoT, Microsoft Azure IoT, IBM platform, Google platforms, and build a different kind of application by using interfacing the cloud platforms or the different technologies here. Okay, so generally, like once if you have some uh, basic knowledge about the particular electronics, so that you can also join this particular course. Otherwise, from the different field, like from the particular electrical or the mechanical, computer science, the students are also generally learn this particular technologies because it's not compulsory that you will be work on some end to end. You will be work on some particular electronics part. Most of the times the particular analytics, because the loss of the startup, loss of the companies generally provide a solution, analytic solution for the IoT part. So but you should have a knowledge about end-to-end domain. Now the manufacturing industry is also implementing this particular part, but you should have a knowledge about that, what is the IoT, what are the different parameter of inside of it, the architecture of it. Then only you'll able to understand or build design some Android applications software for the IoT for the IoT applications. Okay, so let's go with this part. If you have any other questions, so you can also let me know through the chat box. Okay, so let me, when we talk about the IoT domain, so because this is one of the reason you maybe heard about the some edge IoT, fog computing, edge computing, and cloud part. Nowadays, we are also implementing the IoT by interfacing using a different cloud platforms like Microsoft Azure IoT, AWS IoT, or Google IoT platform. So this is one question, the importance of the embedded system into the field of the IoT. Obviously, the embedded system is very important because end-to-end will work on the microcontroller, sensor, actuator. So if you have knowledge about the embedded, this all about the part like different microcontroller programming. So obviously, that's something very a plus point for you and something it will be benefit you to learn and to this particular technology. It will be easy for you to adopt and to learn this all over the part. But if you don't have any particular basic knowledge, so generally we start from the very scratch, from the very basic controller like Arduino, Raspberry Pi, and the microcontroller, microprocessor, architecture, programming of the controller part, and then a different programming language like embedded C, then Python, then different protocols, cloud platforms, protocols, wireless networking technology. So it's something very scratch part. Okay. Yeah, so we're talking about the particular nowadays in the market, the companies are also industry also implementing the edge computing or the fog computing. Okay, because we can build some application of the cloud like AWS IoT, Microsoft Azure IoT, Google IoT platforms, or IBM platforms, and we can easily interface our physical device to different cloud platforms and build end-to-end application. But one of the challenges, like most of the manufacturing industry, it's not possible they should be But in order to connect with the cloud platform, there should be like internet facility into the some industry into the particular industry, so that we can be connect to the cloud platform and share the data, send the particular data to the cloud platform, and then we can build different applications over there. But again, into the most of manufacturing industry is not possible to have the internet connection 24/7. So what we do, we generally work and implement this particular all of the IoT solution on the edge level, on the microcontroller part. And second reason is because we won't, because first the data will be moved to the cloud platform, then in the cloud platform there will be some kind of the process, sometime it will be take for the processing part, like to build the analytic solutions and data pre-processings and all of a part. Then after it will be sent the some what action it should be performed in this particular situation, it will be sent back to the device. So it will be take some 1 or 2 seconds maybe, or maybe the 0.5 or the 1 second. But into the manufacturing industry, we want a reaction, or we want to perform some action within the very friction of the seconds. So in order to do this particular part, we want to implement this all of the things, whatever we are doing on the cloud, like processing, notifications, analytics, this all of the things we want to do on the edge level. On the edge means on the microcontroller part itself. So that's something we generally say this is the edge computing. So the most of the industry, they're also implementing the edge computing part, and AWS and Microsoft Azure. This is a very good solution of AWS Greengrass and Microsoft Azure function. As so use of that we can be easily implement Azure IoT part, Microsoft Azure IoT services, and AWS Greengrass. We can easily implement it on the particular edge level and implement the build the end-to-end applications over there. Second is the fog computing. On the edge computing, we do the all over the part on the edge levels, like on the edge level means on the particular ground or the microcontroller itself, all over the analytics and the predictions, all over the solutions we do over there. Second is the fog computing. On the fog computing, we do this all over things on the server, on the particular gateway, you can say, sorry, on the particular gateway. What is the gateway? Like maybe like there's just some router, okay, and through the router we can be connect to the multiple laptop. So router will be work as a gateway. Okay, so what we can do, there's a loss of the wireless networking technology, there's a base on the gateway systems. Okay, so on the gateway, if you're implementing this all over the part, so that's is we generally say it's the fog computing. Fog means is something middle between edge and your cloud. Okay, cloud is upper layer, edge is lower layer, and fog is something middle layer. So that's is middle layer is particular your gateway. So generally, if you implement this all over the data pre-processing, analytics, this all over things on the particular gateway part, so it's something known as the fog computing. Okay. So these are some different things we generally in the industry nowadays is famous into the market. You can say the edge computing, fog computings, okay, and implementation with the cloud. But it's not necessary into the all of the domains. We generally go with the edge or the fog. It's totally depend on the applications part. Okay, some places like okay, some places like particular edge computing is something good. Some particular for the some kind of the application, you can say the fog computing cloud platform is good. Okay, okay, I'll come back to all of you like Animesh and uh, Surya and all of you. Okay, let me give the one example and let's complete this particular part. Then after we'll discuss into the different, we'll discuss the smart grid and different applications into the detail. Okay, so nowadays what we want, because in the real time when we talk about, we are collecting huge amount of data through the IoT part. So the data may be into the different format. It may be the text, it may be into the audio, video, different kind of the variety kind of the data, right? And it may be because in the real, we are not talking about the 1 MB, 2 MB, we are talking about the GB, beta, terabyte kind of the data, because within the fractions of seconds, we are collecting a huge amount of data. So we should have a such tools so that we can be process those data and do the analytics part. Okay, and with very friction after the analytics part, with a very friction of seconds, we want to perform some action. So our system, our engine should be able to perform this all of the operation into the as soon as possible or within the friction of seconds. So this is something of V3 rule. Into the big data analytics, we also follow volume, variety, and the velocity. Into the IoT domain, what we do generally, we connect to all over the gateway to the some big data analytics, such kind of the tools. So from where we can be processed, because what is the big data? Big data means something. If your system not able to handle those data, then this data become a big data. So we generally use the different big data kind of this engine or solutions to handle with the particular all of a terabyte petabyte format of the data, because in the real time, we within the friction of seconds we are collecting a huge amount of data, right? So we generally connect this that gateway to the such kind of the solutions like big data analytics, and where we can be analyzed all about the data. And once we have some more information, and once our data is clean, and we have some information about our data, we generally use 3 to 4 months of data, and then after we use artificial intelligence kind of the techniques like machine learning, different algorithms to build some predictive maintenance recommendation solution kind of the engine. Generally, OEM company like original equipment manufacturing companies, they also provide a implementation of the IoT, or they also provide a solution implementation of the IoT to the manufacturing industries like Kuka, Fanuc, Siemens, Allen Bradley, ABB, different companies, Rockwell, Bosch. So their platform known as OEM platform, original equipment manufacturing. Okay. Generally, what they do, they generally use a 3 to 4 months of data they collect, and they use a 3 to 4 months of data of any particular machines to design the some predictive maintenance kind of the solutions. Most of industry, they generally use the Siemens platform. Okay, Spear and Bosch, different kind of the platform is something very famous. Into the India also, lots of the industry from the south, and they are generally already implemented this particular part like smart manufacturing industry, and the Bosch kind of the companies, they also provide a solution to the uh, small scale of industry to implement this particular part. Okay, so we discussed that. Like, let me give the one view here. Just give me the 1 second. Let me just draw this particular part, and so that we can be discussed into the detail. Okay, I'll just go through that. Then after, okay, so we'll understand the architecture of it and to end part of it. Okay, so that it will be easy for you to understand all of the architecture, and after that we'll be work on some demo part using to the MQTT protocols, and we'll see that how we can be sh share the different kind of transfer the different kind of the data like text, images, audio, video through the IoT part, and we can connect to the cloud platforms using a different protocols and also work on those data. So the first, let's understand the architecture part. Okay, and if you have any question meanwhile, so you can be also let me know through the chat box. Okay. Otherwise, let me just do one thing here. Okay. So microcontroller is a single chip computer. Okay, it's having the specific RAM, ROM, input, output, but input I/O port, so that we can connect to the different sensor, actuator. Like it's something kind of the single chip computer. Like in your computer, it's having the RAM, ROM, the processor, and you can different input, output ports, so that you can connect to uh, the particular some output devices like projectors, some input devices like keyboard and mouse. So same thing, but it's not programmable. So the microcontroller is something reprogrammable, so that we can be interface the different kind of the sensor, actuator, and you can program it so that you can read those data. It's having the specific RAM, ROM, like in the form of EEPROMs or okay. So you can simply say that it's a single chip computer. We generally use to interface different sensor and actuator, and it's having the different IO pins, analog, digitals, PWM, different kind of the communication bus like I2C, SPI, UART, different kind of the communication bus, so that we can be interfaced with the different ICs and transfer the particular data over there. So we're talking about the particular IoT part, the architecture of the IoT. Okay, so here, as we discussed, suppose that if you have some different physical devices like physical device 1, if you have physical device 2, okay, and suppose that if you have some different physical devices, okay, some kind of the industrial robot, some physical device 3. So what we want to do that, like you have some more mobile phone, like as a user, okay, some mobile applications that we have, okay. So what we want to do that, we want to collect this all over the physical device 1, 2, 3 data on the particular our mobile phone, so that we can be read and work on those data end to end, right? So as we discussed, like here, to implement this all over the part, we can be use some different microcontrollers. We can be use a different kind of microcontrollers, sensor, actuators part. Okay. So what we generally do, we use a different microcontrollers like Arduino, Raspberry Pi, Intel board, okay, Banana Pi. Different boards are stand up. Then after ARM controllers, different STMs, different controllers that we can be use it. Okay, and we use a different, we can also use a different sensor, because normal our physical device don't have an actual sensor, but in order to collect the data from the environment, okay, we use a different sensor based on the applications like temperature, humidity, then after motions, then after uh, 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 light sensor, then after uh, environment, atmospheric pressure, image sensor, different sensor based on the application that we can be use it and interface with the microcontroller. Sometimes we also want to perform some action, so we can be also use the different actuator. Okay, actuator means different servo motor, DC motor, relay module. Whenever you want to perform some action, like if the sensor data, if the sensor data is something more than some kind of the critical level, so automatic machine should be stops. So here we want to perform some action, so we use a different actuators like servo motor, DC motor, stepper motor, relay modules in order to control some things. Okay, and different wireless networking technologies. So there's also the very famous like NFC, near field communication. We use generally into the smart wearable devices. Okay, Wi-Fi, okay, Zigbee. Then after, nowadays for build the particular smart city, the LoRaWAN is also very famous. Sigfox, most of European countries they use the Sigfox. After that, narrowband IoT is also very famous, like a narrowband IoT for the smart city kind of the applications. But the Sigfox and narrowband, this bandwidth is not available into the India. We are generally using the particular LoRaWAN. Okay. and cellular network. So different things we have a particular Bluetooth, NFC, Wi-Fi, Zigbee, LoRaWAN, Sigfox, narrowband IoT, cellular, and we can use such wireless networking technologies to build a wireless network between different physical devices. So one of the application, like one of the things like how to choose the particular wireless networking technology for kind of applications. Okay, so there are lots of the factor which is very important, like power consumption, security features, bandwidth. Okay, and which we generally keep in mind whenever we are generally choosing the wireless networking technologies for our application. Let me give you one example. Nowadays we're using the before some couple of years we generally use a Bluetooth to share the particular data between one mobile phone to another mobile phone, but nowadays we generally use a share it kind of application. It generally use a Wi-Fi. So what is the difference between the both part? Generally the data rate is different whenever we generally share through the Bluetooth and through the kind of share it kind of application. Both security features are different. Both bandwidth are different. Work on different band. Both kind of you can say both power consumption, security features, data rates, range are different. So whenever you want to choose a wireless networking technology, such features we should be keep in mind, and based on that we can choose wireless networking technology for our application. Some is range, bandwidth, okay, security feature, power consumption is very important, and data rate, the speed, you can say, okay, and security features, power consumption, network topology. Network topology part is also the very important, the star and circle different network topology, and one-to-one node, like the particular Zigbee and the particular LoRaWAN is a particular gateway basis, the Wi-Fi is the gateway basis, but the Bluetooth and the NFC is something and node to node, okay, one-to-one node. So it's very important, the range, bandwidth, security feature, power consumptions, data rates, and topology, and some more features. Based on that we can choose a wireless networking technology for our application. So as we discussed, we generally use a microcontroller, sensor, actuator, networking technologies with the particular physical device. Same thing will also use interface with this all over part, like microcontroller, networking technology, actuator, okay, sensor with this device, also with this particular physical device. So you're using the microcontroller, and by interfacing the sensor, actuator, wireless networking technology with the microcontroller, we can build the wireless network between, we can connect the all over the physical devices to the same network, okay. And we can also by you interfacing the sensor, because sensor can sense, if you give the power, then sensor will be sense the data from the its environments, okay. And we can be read this data using the microcontroller, we can program it and read those data. But in order to send the data to the some other physical device, we require a wireless networking technology, some communication channel. So we can be choose a communication channel based on such feature like range, bandwidth, security features, power, or data rates and topology, and we can be transfer those data to other physical device. Then other physical device will perform some actions. If you implement the AI over there or some rules, we can be put it over there. So it will perform some action based on that. Or we can send this data to the cloud also. Now here the clouds will become in the picture. Like suppose that we can connect here, they are suppose that they are the particular machine, okay. In these machines I want to build some application of the particular predictive maintenance. So in this machine, in this particular node, in this node, in this node, in this node, there are some different factor. Due to that, some kind of the failure are coming. So what I'll be do that, I'll using the IoT technologies, okay. There is some cloud platform, this is some cloud, okay. So or using some protocols, we can be share this data to the cloud platforms, and once data on the cloud, we can be use different solutions like analytics, machine learning, and we can do the processing on the particular data, work on data, and build such kind of the applications of the predictive maintenance, such kind of things. So if there's any maintenance will be required, any things will be required, then cloud on the cloud part we can be do that, and it will be send the notifications to the user, okay. So such kind of thing that we can be do to be here, okay. Okay, so here when we talk about the cloud platform, the different cloud platform are very famous into the IoT domain. Okay, like if I talk about the AWS, Macro, Amazon Web Service, AWS IoT solution, Azure, Microsoft Azure solution, IBM platform, Google IoT solutions, Cloud IoT solution, and then after ThingWorks. Okay, and we can connect this all over the cloud platforms by using a different protocols like MQTT, WebSocket, HTTP. Depend on the cloud platform. Then after we can program this using this kind of the protocol. So what is the protocols? So like if you can see, if you open the web browser and enter the any IP address of any particular server like Facebook or like LinkedIn or like TechTrunk.in, so you're able to connect that particular servers and also communicate. Your web browser will able to communicate with that kind of the server. So by default, web browser use the HTTP protocol. So these are the application layer protocols, and for different kind of applications, we can use a different protocols. Like for sending them email through the internet, we generally use the SMTP, POP3, or IMAP, different kind of the protocols. So for IoT domains, we generally use the MQTT protocols, and using the MQTT protocol, we can be easily implement this particular part. And this all over the cloud platform support MQTT protocols, so we can easily use these protocols and program it interface with the particular our microcontroller, so it will be send the push the data to the cloud, and once the data on the cloud, we can be work on those data and build such different kind of the applications over there. Even we'll do the some practicals, we'll do the some demo on the MQTT protocols only. Okay, so this is some kind of the architecture with the cloud platform. And if we talk about the without cloud, if you want to implement, so let me just draw this particular part again so we can be understand it into the. Okay, let me just go with this part. Okay, so you can see here, as we discussed, like we have some physical device and some cloud. We can be use some very famous cloud like AWS, Microsoft Azure, IBM, Google. ThingWorks is very industrial IoT platform. So that's something. Okay, so we can connect to our physical device with the cloud platform using the different protocols. And that's the different protocols like HTTP, MQTT, AMQP. It depends on the cloud platforms. What are the different cloud platform protocols that kind of the cloud platform support? Like what is the protocols like you see, like for sending the email through the internet, for performing for different kind of applications, we use a different protocols. Like our web browser support to HTTP protocol. So using of that, we can be directly connect. We can easily connect to the some server web servers like particular some kind of the servers like TechTrunk.ins or some Google server, LinkedIn servers, Facebook server, and we can our browsers will able to communicate with that server and get the data. Okay, so if our laptop is not connected to the internet, so we won't be able to connect with the particular server. But once it's connected to the internet, so using the protocols by sending the request and the response, we can connect with the servers and get it easily can access the data. So same things, there are the different protocols is very famous like HTTP, MQTT, AMQP, and QoA protocols is very famous. Even for industrials, we use the OPC UA also. Okay, so for the connecting to the PLCs to the server. Okay, because now all of the PLCs support to the OPC UA protocol, so we can connect to the server directly to the PLC also. So using the MQTT, AMQP, QoAP, different protocols, we can connect to the different cloud platforms like AWS support HTTP and MQTT, Azure support AWS, Azure support Microsoft, HTTP, MQTT, and AMQP protocol. IBM support HTTP MQTT, HTTP MQTT, HTTP MQTT. So based on that, we can, like we can be connect it and push that particular data over there. And once our data on the cloud, we can be work on that. We can be do the lots of things, because once you have information for the IoT, for the AI, you should have a data, and for the data, we generally use the IoT. Okay, we can collect a huge amount of data, and then after using the AI techniques, we can work on those particular data part. Okay. So this is the something kind of applications on the, once on the cloud. Once we have a data, we can build recommendation engines. We can build the analytic solutions over there. Okay. So this is something with the cloud. If you're implementing with the edge, so this is the pure microcontroller. So on the microcontroller itself, we do all over the analytics. We collect the sensor. We use the microcontroller. We use the sensors. Okay. We use the we interface with the actuators. Okay. So we also use the different AI techniques on itself on the particular microcontroller part. Some different kind of the AI based algorithms. Okay, we build that, train the algorithms for the into the external world, and then after we just import a train model and put it inside of our microcontroller, so it can be it can do the all over the performs all of the kind of actions. So this is something we, when we do on the particular edge level, this become the edge computing. But here your security feature is very important. Okay, your microcontrollers should be capable, must be capable to handle this all of the things. And when we do the particular this, because suppose that what happen if we have multiple physical devices, okay, like this one. Now suppose that I'm using a particular Wi-Fi module router and connect to this all over things to the my router. Okay, all over this thing having the particular Wi-Fi module, my physical devices, so we can be connected to the Wi-Fi router like to here. So it become a gateway, right? If you're implementing the all over the particular analytics parts to be here, so if we say this is the fog computing, this is the edge computing, and this is with the cloud part. Okay, and if we can also move the data from particular gateway to the cloud platforms. So if I say into the real time, what happened the architecture, so in the particular real time, so in the so in the real time, we generally use our different physical devices, and with each physical devices, we can be use a microcontroller, sensor, actuator, wireless. Suppose the wireless networking technology as a Wi-Fi modules I'm using, but it depend. Okay, it's depend on the applications. We can choose wireless networking technology. We already discussed the based on the security features, topology, bandwidth, and we can be choose wireless networking technologies, the sensor, actuator, networking technology. Same thing here also. Okay, all of the part. And after that, there's a one gateway, like there's a one gateway like router, and you can connect this all our things to the gateway, and we connect to the gateway to the cloud part using the different protocols like HTTP, MQTT, and we can directly connect to the cloud also. Also we have options, we can directly connect to the internet here and connect to the cloud part. It's totally depend on the applications that we are using, wireless networking technologies. But if you have a Wi-Fi, so obviously we require to particular gateway, and then gateway, our particular system is connected to the gateway, and then gateway to we can connect to the cloud platform. If you're using a LoRaWAN, so in the LoRaWAN wireless networking technology, this is something a gateway based system, so we generally connect to the gateway to the cloud part. Okay, and different kind of the particular protocols we can be easily connect to the cloud, and we can be do the all of the processing on the cloud, and based on that we can be do all of the things on the cloud. If you're implementing all the fog computing, so we can be doing the fog on the particular gateway. If you're doing the edge computing, so we can do on the edge part. Okay, so definitely like the one questions, what is the Wi-Fi router has a long the range of it. Okay, so like as we discussed, like here you can see, let me come back to here. I'll come back to this all over the part. You can see here. So as a Zigbee that we have, the Zigbee is now the Zigbee also launched a different kind of the product for especially for the IoT, and that range is something up to 1 kilometer. So normal range was something 10 to 100 meter, but now recently like Zigbee launched a different new product for the especially for the IoT domain. So its range is something uh, 1 kilometer, and it's based on the particular frequency 2.4 gigahertz bandwidth. Data rate is something to 50 kbps. Okay, for the Wi-Fi is something is now we have a particular based on the 2.4 of to the 5 gigahertz. Okay, approximate is something of 50 meter, and data rate is 600 mbps, but it's normally 150 200 mbps based on that, right? So like you can see we have a different wireless networking technologies like Zigbee, okay, and then after Zigbee, Wi-Fi, Bluetooth. Recently, like Bluetooth also launched the new BLE 5.0. Right now we are using the BLE 4 or BLE 4.2. The BLE Bluetooth recently launched the new product that is something a gateway based system, not end to end, and it is the based on the BLE 5.0. And its range is something also very good, something 50 to 150 meters, okay, more than that, and the data rate is around to the 1 mbps. And Jetway is also the very because you can see we have a Bluetooth, Jetway, NFC is something ranges 10 centimeter. Data rate is 100 to 420 kbps. It's used into the smart wearable devices like smart ring, smart. So what is the gateway system? This is one question from the Manish. Okay, let me discuss this. You can see here, this is the gateway. You can see if I talk about nowadays, the LoRaWAN technologies is very famous in the market to design the smart city. Because of that, one of the reason is this is something very long range and LPWAN based technology. Okay, LPWAN technologies means which can be work on the low power and cover the wide area. If we talk about suppose if you want to implement the particular IoT into the field, so in the field we cannot use the cellular network because some devices generally work on very small battery. So generally the cellular network consume very high power to transfer the particular data. Okay, so we cannot use the cellular network for long range into the field part because most of the devices work on very small battery. So here we generally use the particular, we want to something wireless networking technology which can work on very low power and cover the wide area. So LoRaWAN is one of the solution, and it's also there's no any kind of the bandwidth license we need to purchase is open bandwidth. That's why is in the India is very famous nowadays, and its architecture is something gateway based system, and its range is something a kind of up to 15 kilometer, 15 kilometer, 15. So generally it's suppose that if you want to connect your mobile phone to the uh, router, so in your mobile phone there should be kind of a Wi-Fi module. So same thing, we generally use a LoRa and LoRaWAN and non modules with our particular microcontroller, and there's a one gateway, like your router is the gateway, and you generally connect your router is connected to the internet, okay, through your particular internet service provider, and we generally connect our mobile phone to the router, that particular, right. So your particular router is something kind of the gateway, you can say. So here is the gateway, we connect to the all of the AND node to the gateway, and using a 3G 4G module we can connect to the gateway to the some kind of cloud platform smart. So there's a question from Animesh, what is the job opportunity in the field of IoT? So you can see the loss of all of the companies like logistic, healthcare, manufacturing, all over the sectors they are working into the IoT domain. So obviously there's the loss of the job factor inside of it into the manufacturing domain, into the electronics, into the microcontroller, firmware. Because suppose that if you are nowadays if you are just interfacing any single thing like USB or anything with your computer, we require sometimes update the firmware, right? So you can see we are going to interface the loss of sensor with the microcontroller, and microcontroller is also single chip computer. So to design the different firmware, update the firmware, design different Android applications, software tools, analytic solutions, work with IoT data, embedded systems, okay, and then cloud architecture as your AWS IoT architecture, Azure IoT architecture to work with different cloud solutions. So there's a lot of the job opportunity inside of it as an IoT engineer, as a IoT cloud architectures and all part. The one questions from the Mukul, what is the security features of the LoRaWAN? So obviously there's a, because when we work on any kind of the wireless networking technologies, we can be interface different kind of the security features. Like suppose if you're connecting with the any cloud solutions, if you're connecting to the sensor node to the gateway, okay, if you're connecting a sensor node to the gateway, so we can be enable the different kind of the security features like in data encryption, okay, and so that the third party won't be able to understand the actual data over there, okay. The data encryption part we can be use it, or then after whenever we connect to the gateway to the some cloud platforms, we can be also use the transport layer security, like which when we talk about HTTP to HTTPS. So okay, so we generally enable the transport layer security, the TLS SSL, we can enable it. So third person won't be able to read our data, and also won't be able to access our particular data part. So SSL, TLS layer security, data encryptions that we can be using. If we talk about the specific hardware security, is depend on your controller. Like in the IoT domains, we work on hardware security, wireless networking technology security, and database security, data security, cloud security, all over the domains part. It's depend on the what different companies, what are the module that you are purchasing, because there's lots of the company in the market, they provide all LoRa uh, hardware part. So maybe some companies provide authentication kind of features. So third persons, if the third person want to access it, so they use some kind of the user and the password, then also only able to access the particular or connect the particular network part. We can't connect to the node directly to the monitor. No, we cannot connect it. There's just some gateway, and through the gateway we can connect to the monitor. Like obviously your mobile, you don't won't be able to directly connect to your Wi-Fi router. In your mobile there's a Wi-Fi module, and use of that you can be connect, we generally connect to the Wi-Fi router. If you just have a mobile phone without Wi-Fi module, so you won't be able to connect to the router, right? If you have experience with the Arduino, so in the Arduino microcontroller, it do not have the Wi-Fi module, so we cannot connect to the Wi-Fi network or the router. But into the Raspberry Pi itself, it inbuilt it having the particular Wi-Fi module, so you can be connect with the Wi-Fi router or the internet, right? So we cannot directly connect it because this is something a gateway-based system, and through the gateway we can do the monitoring all of the data. Okay. So this is some the architecture of the LoRaWAN. So you can see we have a different, see, most of the different countries like into the Australia and Netherlands. So they are Germany. They're implementing they're using the Sigfox into the agriculture sector. Now in the India, this bandwidth is not available. So we generally use the LoRaWAN for into the agriculture sector, into the smart city, different kind of the applications, different field. Okay, same thing you can see here also. There's a different sensor also. Based on that, we can be used based on our applications like DHT11 temperature and humidity, DHT22 temperature and humidity. It's give more precise value as compared to the DHT11. Soil sensor to check or to sense the moisture level into the soil. Then after BMP 180, atmospheric pressure, SCSR04 ultrasonic sensor to calculate the distance, IR sensor to detect the particular objects, and BL3115A. So this is also the atmospheric pressure sensor. Then PIR is the motion sensor, LDR photodiode, photo transistor. This all of the things are light sensor. So there's a lots of sensor, image sensor, MQ3, MQ2, MQ7, MQ11, the standard gas sensor like butane, methane, different gas sensors are. The photo transistors and photodiode and LDR, this all over the light sensor. But based on intensity of the light, is give the different, is change its resistivity. Okay, based on the whatever the amount of the light will be fall on the particular sensor. Okay, it's generally change the resistivity of this particular sensor. So this is also known as a light sensor. So And if I talk about the particular, let me start from here. You can see we talk about the different controller also into the IoT domain. Like the Arduino Uno is the very basic one, is very cheap and widely used in the market also, because it's having a different kind of the pins like analog, digital, PWM. It support to I2C, SPI, and UART, different kind of the communication bus. We can easily program it, interface with the different sensor, actuator, wireless networking technologies, and implement into the real time. Okay. After that, ESP826 is the Wi-Fi module. So we can using the USB, it having the two GPIO pins, and the golden color you can see is the antenna on the chip. So we can also upload the program inside of this part, because the single chip is also having the two GPIO pins. So using the USB to real converter, we can easily upload the program, and it's also known as the Wi-Fi module. So we can also connect to the our Arduino and make it the Wi-Fi enable by using the UART communication protocols. We can connect with this ESP module to the Arduino and make it the Wi-Fi enable, because in our Arduino module, in this module, there's no any Bluetooth and Wi-Fi, inbuilt Bluetooth and the Wi-Fi. So we can use the external Bluetooth and the Wi-Fi and make it the Bluetooth and Wi-Fi enable part. After that, we can see we have Intel board also in the market. Intel Galileo, the different versions of the Intel Galileo part, Banana Pi. Okay. After that, we have Beaglebone Black. We can be using Beaglebone Black and Node MCU. So like ESP26612E version known as the Node MCU part. So Flutter, then chip, and so these are the different microcontroller which are the very famous, and we can be use it to build to interface different sensor actuator. So what are the difference between the different microcontroller? Are the security features? What are the different security features into the is microcontroller? What are the number of the particular analog digital pins, the inbuilt supported OS, what about the storage, what about the number of the pins, so what about the different wire communication protocol it support, like I2C, SPI, UART, how many number of the PWM pins, number of analog digital pins, number of wireless networking technology inbuilt, like some board support to the LoRaWAN, some board support to the LoRaWAN, NFC, Bluetooth, Zigbee, some board support only the Wi-Fi and the Bluetooth. So based on such kind of the features, we can be choose a microcontroller for all applications part. Or these are some company who manufacture the different microcontroller for IoT applications, like Broadcom, Intel, MediaTek, Qualcomm, Speeds, Texas Instruments, very standard companies who generally manufacture different kind of uh, different kind of the particular uh, microcontroller for IoT applications part. Okay, so different actuators also, like we use the servo motor, stepper motor, DC motor, relay module to control the particular high voltage. So generally we use a different actuators into the industries also to control the particular uh, any specific parts, or any to perform the some specific actions over there. Okay. So what I'm going to do that, let's go with some demo part and let's try to implement this particular things, and then after will we come back and discuss the different kind of actuator. There's one question, what is the actuator? So it's a very simple, there's a different definition from the actuator, which you can say is generally convert the mechanical energy, sorry, electrical energy into the different forms, like a force, or different kind of the energies, like a force or the particular rotations or different kind part. But you can also define this particular actuator as the part of any machine which is responsible for to all over the control or perform some action. Generally into the big industry, we use the big kind of the machines, we use servo motor, DC motor, and whenever you by controlling the servo motor, DC motor, or stepper motor, you can control the full machines. Or by to control the stop the particular machine, if you can cut the power supply, so we can also stop the particular machine. So we can be use a relay module to control the much higher electrical voltage. So this is also something known as a kind of actuator. Okay, so let me just go back to the one demo part of it, and Okay. Okay, so right now I'm just going to discuss about the MQTT protocols. Okay, so into the IoT domain, the MQTT protocol is very famous. So what happened, like we generally use the HTTP protocol for different applications part, and HTTP protocol based on the request and response basis. By sending, whenever we enter the any app address into the web browser, it send the particular request to the web browser, so server, and server send the data in the form of the response. And by using the request and response method, we can be easily connect and share the information or data. So this is something based on the HTTP protocol. Okay, so in the IoT domain, we generally mostly we work on MQTT protocols, and all over the cloud standard cloud platform support to the MQTT protocol, the message queuing telemetry transfer protocol. Okay, so all of the protocol. So let's understand the architecture, and after that we'll implement it. Okay. Okay, so as we discussed here, there's no any client and server. The architecture of MQTT protocol is something based on publish and subscribe method. It's based on publish and subscribe, and there's a main two features. One is MQTT client, and another is MQTT broker. Okay, because this is something very important. Let me uh, let's discuss this particular part into the detail. As we discussed into the MQTT protocol, there are mainly two part. Is a client, MQTT client, and MQTT broker. Okay, and its architecture is something based on publish and subscribe. So what is the client? Clients are the end user. End user means, if suppose if I want to send some data to you, so both like known as the client. The broker is something middle party. Okay, because in the according to the MQTT architecture, MQTT protocol architecture, both client or both node cannot directly communicate with each other. Like suppose if I want to send some data to you, so we cannot directly communicate with each other. There is some broker, and through the broker we can be communicate. Like suppose if you want to purchase some property, so we generally connect to the broker, and the broker is schedule some meeting with the particular owner of that particular property, or that kind of the house, or that kind of the properties, and then we can share our information through the broker only. So same thing here is the broker is something middle party, and it's used to access the data between the both and to end clients. So suppose if I want to send some data to you, the first I'll send my data to the broker, and broker will send the data to you. Okay, broker is something exchanger. So broker is some kind of the software that we can be installed into the cloud, or that we can install into the particular our laptop, and it will work as a broker. And use of the broker is to access or the route the message between the different clients. So one question becomes then, how the broker will be identify that this message is belongs to this user. Okay, for that broker is used something topic name. Topic name is user defined. Like suppose that first I'll be send my data. Suppose if I want to send some data to you, so I'll send some data with some topic name. Topic name, suppose that I can choose ABCD, some kind of the code. Okay, ABCD. I'll be send my data to the broker using some code ABCD. And if you know that code, so you have to subscribe once on the broker, and then broker will be rechecked with the ABCD. There's any kind of data. If there's any kind of data, it will be sent to you. Broker is not going to save any kind of data. Broker is just used to route the message between both client. Okay, so if suppose that if I want to send some data to you, so I'll be use some topic name like ABCD. Okay, and both parties should have the information about that, what is the topic name used by other client. Okay, so if I'm using the ABCD topic name to send some message to the broker, then if you know that topic name, then first you have to subscribe on the broker, and then broker will be checked, is there any data available with the ABCD, so it will be sent to you. So I'm sending my data to the broker with some topic name, so it's known as a publisher. This client known as a publisher, and you are subscribing to using the topic name to the broker, so you known as a subscriber. So this architecture is something publish and subscriber. First is generally if the client is publishing, sending their data to the broker with the topic name, so that client known as a publisher. If the client is subscribing to the topic on the broker, so that client known as a subscriber. Okay, so let's understand this. Here you can see if the temperature sensor want to send the data to the mobile phone or the laptop, so temperature sensor can send the data to the broker using some topic name like publish 21 degrees Celsius. Publish is something kind of the topic name. If the subscriber know that topic name, so for it have to subscribe on the broker, and the broker will be recheck there's any data available with this topic name, so it will be resent to the sent to the particular corresponding subscriber. And what is the broker? Broker is a different kind of the software that we can be use it, that we can be install it. The MQTT protocol is designed by the IBM, and there are lots of the open source broker are available that we can be installed in our system, and it will be work as a broker like Mosquito, Mosca, HiveMQ. These are the different broker that we can be installed in our system or the cloud platform, and it will work as a broker. So what I'm going to do that I'm just going to implement one example. What is the term subscriber means here? Subscriber is the receiver part. You can see if suppose that I'm sending some data and you want to receive those data, so I'm sending this data using some topic name, and using the topic name the broker will be identify that this message is belongs to this person. Okay, if suppose that if you know that particular topic name, then first you have to subscribe using that topic name to the broker. Like suppose that I'm sending the data using the ABCD, so ABCD is a topic name. So the first you'll have to, if you want to receive your data, then first you have to subscribe to the broker using the ABCD topic name. And once you'll be subscribed, then the broker will be recheck there's any data available with this topic name. So if it's available, so then it will be sent to you. So you are going to subscribe using the topic name. Okay, so you known as a subscriber. Okay, the subscribing means sending the request with the particular ABCD topic name to the broker. You can say the broker is some kind of the server, and you are using the ABCD, and using the ABCD topic name you are sending the request to the server, and server will be send the data back to you. But generally we don't use the like kind of the server and the request kind of the terms into the MQTT protocol, but you can be understand it use of it. Okay, okay, so let me just go with one example. Okay, so I'm using the particular Python as a programming language for it, and so you can be used this particular, just wait a minute. Okay, let me, so just do one thing. What I'm going to do that, okay, the first you won't be able to understand it, so all of you can download one Android applications. Okay, so what I'm going to into the real time we do the programming, and through the programming will implement this particular part. But right now I'm just using the some simulator, and use of that we can be understand it. But into the real time we use a Python, and the one of the library of the Python, that is the Paho MQTT, that kind of the packages that will be use it. And use of that, that's a designed by the Eclipse Foundation, with a standard package and of the particular the Python, and use of that we can connect with the AWS, Azure, Google, and different cloud platform, and share the data over there. Okay, okay, so right now you can be do one thing. So just let me show you here. You can just download the, if you're all of you the Android user, so you can just download the MQTT client kind of the applications in your mobile phone. From the Play Store, you can download the MQTT client designed by the web neurons. Okay, designed by the web neurons. You can just download it Android application in your mobile phone. Okay, let me know once you're done with this particular part so that I'll be guide you how to use this particular applications. MQTT client. This is the app MQTT space client designed by the web neurons. MQTT client. Okay, done. Great. So now you can just open that particular application. Okay, just open that particular application. So you'll get some one slide. So on the right bottom side, you'll get some plus kind of sign. Okay, please give me the confirmation through the chat box also. The right bottom, you'll get some plus sign. Okay, right bottom. So just click on that. Okay, click on that. There will be some second slide will be open over there. Some second slides will be appear over there. So on this second options, you will get options like nickname. You can see on the second option is a nickname. You can just give this some name like A B C D X Y Z ABC, any name. You can either you can be just define you some particular name X Y Z whatever. Okay, after that you can move down. Just click on the plus sign. Whenever you'll open the application, on the right bottom you'll get a plus sign. Click on the plus sign, and after that some second slide will be appear. So over there, click on the nickname and give the any name, and then after press OK. After that, move down and you'll get options like host. Okay, so in the host, mention like broker dot hive mq.com into the small letter only. Into the host, mention broker.hivemq.com. This is the broker address of the broker. So in the host, just write down broker.hivemq.com into the small letter only. Okay, broker.hivemq.com. After that, by default, the port is 183, so you don't need to do anything. After that, move down, you'll get options like client ID. So here you can give the some unique name like XYZ, any random thing. It should be something unique. Okay. So random, you can type anything over there. First, give the nickname, give the host, give the client ID as a something unique name. And after that, the first option is enable. You can see enable. So move the slide over there. This is the first option. First option is something enable. So the move the slider over there, right? After that, on the menu, you will get options on the menu. If you can see on the same page, on the same slide, on the menu, on the top, you will see there's a something add broker. They will be mentioned like add broker, and the right side of it, there's a one logo. So if you click over there, so you can save this all over the information. Okay, the first, give the nickname. Then after, define the host as a broker.hivemq.com. After that, define the client ID as something unique name. After that, on the first on the top, the option is enabled. Then move the slider over there. After that, on the menu, there's an add broker, and you'll get options like on the add broker, the right side of it, there's a one logo. Just click on that so you can save this all of the information. And after that, you'll get a some second slider over there, and there will be some small box will be appear. Okay. After that, once you click on that logo, some small box will be appear. Just click on that. Click on that box. You'll get options like subscribe to a topic. You'll get options like subscribe to a topic, right? On the top, on mains, write down ABCD and just click on subscribe. Okay, do one thing. If you click on that particular box, you'll get options like subscribe to a topic. Just write down ABCD and then after click on subscribe. Let me know if if all of you will able to receive the messages like www.techtrunk.in. Just give me the confirmation if you're able to receive this kind of the messages. On the topic, just mention like ABCD. Make sure that message is ABCD and your mobile should be connected to the internet. Can you give me the confirmation from all of you? Will you able to receive the message? Let me know all of you. Will you able to receive the message like www.techtrunk.in? Okay. Anyone, all of you, like, will you able to receive the message? Other participant, can you please give the confirmation? Make sure that your laptop should be connected to the internet. Oh, great. So make sure that your particular all over the name of the broker is should be the correct like broker.himq.com, or the topic name must be like ABCD. Then only you'll able to receive the message. So right now I'm just doing through the simulator, but the real time will write up your code over there and will do implement over there. Okay. Yeah, sure that. What you need to do that first, open the app, click on the right sign. So some second slide will be appear over there. Click on the nickname, like you can give the any name like ABCD XYZ whatever. Host broker.hivemq.com. Make sure that it should be must be into the small letter. Client ID, you can give the any ID over there. You can define any ID. After that, you can move. You can go and you can just enable it. In the enable, you need to move the slider. And after, on the top, on the menu, there's an ad broker. The right side of it, there's a one logo. So just click on that logo so you can save this all over the information. After that, into the some second slide will be appear, and in that there will be this small box, and if you click on that particular box, you'll get options like subscribe to a topic. So in that, just mention like ABCD and click on subscribe so that you'll able to receive the message. And if you can see right now, if I'm just publishing the message, only the same time you'll able to receive the messages. You need to move the slider. Okay, enable the right side of it, there's some slider. Through hand you can just move the slider. Okay, then after, just save it again, save it, and then after just on the particular topic, just write down ABCD and you'll able to receive the message. Okay, great. Okay, so this is the like right now we are through the simulator we are doing, but in the real time we'll understand the all over the program and we'll write a code and we'll understand the architecture and do this particular part. You'll able to control the any machine, anything from anywhere. You'll able to monitor the all our data, and then after we can also able to work on data. We can also interface the augmented reality with this particular part. Okay, so we can be convert and work on the particular data also. It also in the IoT into the particular IoT domain, we generally work on MQTT, HTTP, CoAP, and different. Okay, so username and the particular password, we can define some authentications, and we are not using any security features. So we can also use the security features because uh, we want to do the secure stabilize a kind of the secure communication or channel. So transport layer we can use enable the SSL TLS security. You heard like some websites start with HTTP or some websites start with use the HTTP only. So as means SSL secure, it's used different certificate and provide the encryption and also data security, network security part. So we can also enable the transport layer security and create the secure channel in order to improve the security features. So for that, we also need to implement attach some of the different certificate like public key, private key, digital certificate, and part. Use the ABCD, not ABC, Manish. Use the ABCD and then after click on subscribe because topic name is using ABCD. Message Unique Telemetry Transport, the MQTT protocol. Okay. Use the ABCD and then after click on the subscribe, so you'll able to receive the message. Okay. So it's very famous, even the AWS, Azure, and the IBM, Google, ThinkWorks, all of the cloud platforms support to MQTT protocol. So we can be connected and work. Maybe Manish, there's some kind of the issue from your side. Maybe you missed some kind of the step, so that's why you won't be able to. You can just repeat. We'll share this video, then you can repeat again. Okay. Okay. So these are different cloud platforms, very standard like AWS, Azure, IBM, ThinkWorks, and this all of the cloud platforms support to the. Once you'll be subscribed, you'll able to receive the message like www.tectron.in that I am sending from here. Okay, don't worry, like all of you, if you won't be able to receive the message, you can will share this particular video. You can just repeat and you can do it again. Okay. Yeah, these are the different feature of quality of service, retain, and certificate, transport security, will message, and all. So there are lots different features of it. The quality of service, generally the MQTT protocol also support the quality of service 0, 1, and 2. This is something like agreement between the broker and the sender and receiver, like how they want the particular service. Like, so there's something maximum, minimum. So that will be discussed into the detail into our training part. Let me just give the one brief idea about it, what we are going to do and what will be generally covered in our training program of the IoT part. Okay, let me give this particular general idea. So generally we work on IoT development, security, analytics. Okay, and in the development part we work on Arduino, Raspberry Pi, Bluetooth, uh, and different sensor actuator and different cloud platforms like AWS, Azure, and protocols like HTTP, MQTT, and CoAP. And we'll see that how to design this IoT, all of the IoT end-to-end applications. And we also work on some little bit machine learning techniques. So work on IoT data and design some predictive maintenance kind of the solution. We'll also work on the different security features like encryptions using the cryptography techniques and using the how to enable the SSL TLS security for creating enable the TL transport layer security by using the different certificate like public key, private key, digital certificates. What are the different features on the hardware security part that we also generally discuss and into the detail during the training part, and AWS IoT platform and Azure into the very detail. And after that, we also work on different augmented reality kind of the concepts, how to start with the Unity, Vuforia, different kind of the platform, and design the IoT augmented reality kind of application, and then interface with the IoT part using to the MQTT protocol. So remote maintenance kind of the big projects or very cool projects that we can be doing. The Hadoop platform is not something there's no kind, the Hadoop is totally different from here. Okay. Okay. So let me know all of you. In this way, generally we work on we generally cover around to the 40 to 50 hours of the particular duration of we have a kind of the different kind of the training program, so the 40 to 50 hours, and that we generally cover a different microcontroller, sensor, actuator, and this is the industry certifications also, the industrial very standard certifications you can also get after the complete of this particular training part. Okay, and the internship support also. So let me know all of you if you have any question till now. You can just let me know. You can be ask me if you have any question. All of you, if you have any question, then please let me know. And you can also, what is the job profile in the particular IoT field? Yeah, IoT engineer, embedded engineer, IoT architecture, cloud architecture, IoT solution. So different kind of the job profile, and very, if you have some from the beginner, from the very experienced persons, both profile candidate can be moved in this particular the profile. So this is the online training program, and for the more information, you can also visit our websites www.techtrunk.in. Okay. Yeah, is communication protocols, application layer protocol, right? Last AI webinar certificate I did not receive yet. Okay, you can send our mails regarding to this particular part. Do we get any certificate for attending the workshop, and what is the cloud platforms? And okay. So like first, all of you, like here as we discussed, because the most of the participants don't have a basic knowledge about the programming and the embedded system. So if you don't have any, because we start from generally from the very scratch and the beginning level, so you don't require any prerequisites for it. Like if you are very beginner in this particular field, like because we start from the very scratch level, like what is the microcontroller, what is the microprocessor, how to program it, how to interface LED sensor, actuator, and how to program this all over part. Then after, to start with the different wireless networking technologies, like how to interface the Bluetooth, Wi-Fi, connect with the particular internet, work on the particular protocols, start with the very scratch with the programming language like embedded systems and the Python's part, very scratch level. And we also start with the machine learning, and to very scratch level, you don't require to the any pre-request for it. And but after this end of the training, you'll able to work on the different industrial projects, because we work on spend the more than 40 to 50 hours on this, work on augmented reality, cloud platforms, AWS, IoT, and different platforms. We spend the times and work on different projects also. The co-op is used for the constant application. Like whenever we talk about the constant, there's a one question: what is the difference between the MQTT and the co-op? Okay, on the security aspect. So obviously, like co-op is generally, if we don't, we cannot use it to directly connect with a particular your clouds and all part. We generally use for the constant devices. Okay, whenever if you have some proxies and kind of the challenges, so in such systems we can be use a co-op protocol. It's architecture in the client and server. So the co-op is something good for the constant devices, and for proxies kind of the systems, so we can be use a co-op to over the connect. Co-op is something more secure, but again the MQTT is also a very much secure protocol. So co-op is something very new and very recent in the market. Okay, there's an also lots of the resources also available on the co-op protocol, but maybe in the future for the constant devices we can be use the co-op protocol. Tomorrow will be something different. Okay, so if you have any other information, like kind of the training certifications or the course content part, detailed course content or the particular all over the anything, so you can also visit our website, that techtrunk.in, techtrunk.in. Okay, you'll get a complete information, or you can also send us mail regarding to this particular part. You can go to the website. Okay, so let me know all of you if you have any question. If you have any question, anything, please let me know. For this attending the certification, generally we don't provide the attending certification, but if you join our training program, that definitely we generally provide a standard certifications for it. The certification for this one definitely will our team will be send you the mail regarding to this particular part. Okay, or you can also send a mail regarding to the certificate. You will get a complete information about it. For that, we'll send the emails to all of you regarding to the video and tutorial. The PDF part will share to you very soon within the till Monday, like working days. We'll share this particular all of the details on your personal email ID. Okay, so Zigbee, NFC, and LoRaWAN, Sigfox. These are the different wireless networking technologies. Zigbee is also like kind of the gateway-based system. So like kind of the LoRaWAN, there's a one gateway, and there are different kind of the AND nodes we can be interfaced with the microcontroller and connect to the Zigbee network. So to build a local network, like based on their range, like Bluetooth having the one particular range. So Zigbee is also having the one particular range. Recently, Zigbee is launched new product for the IoT domain. Its range is something up to 1 kilometer. So we can be built, we can connect into the 1 kilometer range. We can have one gateway, we can be used it, and around to the 1 kilometer range, we can be connect to the multiple and node devices to the Zigbee and communicate with each other. So this is something like online training program, and in that will be discussed this all of the part like Zigbee, Bluetooth, Wi-Fi, and the cloud platforms. In the cloud, we'll see that how to connect with the cloud platform using the HTTP MQTT protocol, and to work on the cloud platforms to store the data, build a notification service. So if anything will be happen, so you'll get a notification through the email or SMS. Okay, by using the AWS services, Amazon Web Services, AWS IoT part, and to work on the data, like to do the analytics solution, store the data into the DynamoDB and S3 bucket. Definitely both things we require and we work on some embedded hardware like Raspberry Pi and controller, sensor, actuator, and some software also. Okay, for the IoT domain. For nowadays the most of into the job into the cloud architecture like AWS, Azure, and IBM. There are also the current projects into the smart city manufacturing industry that are implementing this particular part. Okay. No, Sigfox, we cannot implement it here because that bandwidth is not available. Most of the European countries that are using the Sigfox. In the India, we generally work on LoRaWAN. Okay, I hope it's fine for all of you. So we'll share you this all of the PPT and tutorial through the email. And if you any detail, if you require, you can also reach us through you can visit our website and you can send us the mail regarding to this particular part. Okay. And okay, so now I'm just going to wind up this particular session. Okay. Okay, then thank you to all of you. If you have any question, you can please let me know. Okay. Now, otherwise we'll end the particular sessions to be here. Okay, then thank you to all of you. Have a good day. And no, it's not Udemy course. Use the online courses. So you can also join us into the online training part, and where we'll be discuss this all the things into the detail. That's something the 40 to 50 hours of the training part. And there's something we can also design very good. You can also learn the augmented reality and how to build the applications with the augmented reality with the IoT using to the Unity and Web4 as kind of the cool platforms. And it will be live implementation part. There will be some webcams and where I'll be the trainer will be do this all of the things, and you'll able to learn this all of the thing through the live part. Definitely, you can reach us, or you can just visit to our websites. You can contact us, www.techtrunk.in. You'll get all of the detail, and we'll also send you the mail with the tutorials, videos, and this all about the regarding to the fees and course content, complete course content, all of the part. Yeah, definitely, you'll get a certification part. Okay, sure. Yeah, like you'll get a definitely certificate this particular part. Yeah, there's also you can we have also the self-placed videos for the IoT part. Okay, you can also reach us regarding to this particular part. You can send us mail regarding to this. If you're looking for, if you want to join the online training, you can also join the online instructor training. Otherwise, there's lots of we have a self-placed video, so you can also um, uh, send the requirement for the self-placed videos part. Okay. Okay, then thank you to all of you. Have a good day. I'm just going to end this session. Hello. Hello. Mhm.